And have a look where.
You're because when you left yesterday, you were going to go and have a look at your belief or understanding of uphill rivers, weren't you?
Since we were discussing it yesterday, I didn't look into it actually. It was more I didn't leave. I was muted or something. I don't know. Just left.
You
But no, I haven't looked into it since yesterday. Sorry.
so you just know as much about your reading in the book, or you read it. That's fine.
Um, yeah, I mean, I know as much as I did as I did yesterday. I discussed it a bit over at Gems. It's surprising that a lot of them held the viewpoint you guys hold, that it's impossible to happen. It's only once I showed them the info and explained it to them more, they all kind of opened up to the idea
They opened up to the idea of water
that
flowing
it
on.
could be possible.
Oh, just that it's possibility.
Because they don't fully understand it either, so obviously they're not going to accept something they don't understand. They're not going to outright reject it as well.
Okay, so you you just said you didn't go and look into it. You just went over there and
And
tried to
discussed it
with them, and they opened up to the chance of it.
Impossible, yes, based on how I explained it.
Oh, I noticed when you came into the chat earlier, you came in with the gravity thing, right?
Yes.
Well, isn't that sort of like what like how would that work with an uphill river, or the possibility of a uphill river? What sort of possibilities would you have to give to that G, do you think, logically, to have the possibility of a uphill river?
Well, in order for a river to go uphill and work against the force of gravity, you would need a force stronger than that. You'd also need to have a situation where to find it as uphill would say that the mouth of the river is further away. No, it's closer. The center source in the mouth is where it ends, right? Okay, so the mouth of the river is further away from the center of the earth, the source of the river. You would need to believe that the earth is flat, is curved, is a spheroid, and it's spinning on its axis, which causes it to become oblate or spread out at its equator.
So you need to prove you're begging the question fallacies before you can prove your river runs or flows uphill.
But sorry,
So
no,
I
wait a
would need
minute,
to prove
Nate.
that to you.
Are you saying that the R value would have to be greater, and the water would follow the path to a greater R value? I'm just talking geometrically, and obviously we're just sort of imagining what would happen if water would work on your sphere model that you have. Are you imagining that a lower value R would the water would go from that value to a longer R value on the sphere that you're imagining?
The water would move from a smaller radius to a larger radius? I don't quite understand.
Well,
Like,
but isn't that what you're saying? Something that's further away from the center is like the radius value is
oh,
getting
yes,
longer, right?
yes,
Geometrically.
yes.
Right, so what you're imagining is that the water, were it to be on a sphere, would go to a higher radius value. Is that like a natural property of water on a sphere?
Natural property of water is that water subjects itself to the forces acting.
Right, so it would go towards the higher radius value.
Yes.
Really?
Because there must be a force stronger than gravity working on the water.
There must be. in order for that to happen, are you saying? Or on an
The
imaginary
specific-
sphere, if we imagine water that must go to uphill to a larger radius value, then in order to imagine that correctly, we have to imagine a force that is acting opposite to the imagined force of gravity that you have. Yeah?
Not opposite, but stronger than gravity. Yes, you have to imagine all of that.
Wow, that's some imagination.
It is.
It is.
If you wanted to imagine it, or you could
Is-
just verify it
is
for
that what
yourself
you were
and see that
imagining?
it's true.
Is that what you were imagining over at Gem's server when you were imagining all of that? And they were opening
I
up to the
imagined it,
possibility
Gary.
of that, Worthy, because you were so convincing.
I imagined it here as well.
Pardon?
Listen, like I said, I imagined the same thing here as well. And, you know, I've been honest and open in the fact that I don't fully understand how it works. That is the basic understanding I have. The Mississippi River flowing uphill.
Wow.
You guys don't have to accept it. I'm not trying to convince you that it's true. I'm just
well-
telling you that's how I understand it.
That's fine. Like I'm not so sure you'd be able to convince anybody really, but you did
I
good
doubt
well
it.
at Gems. You think?
I don't think so. Because like I said, I just made them more open to the idea.
Okay.
I doubt most of them still accept it.
I'll go over there and check, see, because
You should.
this is fascinating topic for me.
For me as well, man.
Yeah. Have you found anyone else that has an uphill river? Because I mean, it sounds like it might be quite a
Apparently-
common occurrence.
Apparently it is. Apparently a lot of underground rivers flow uphill, especially in the polar regions, in the Arctic and the Antarctic.
Underground
A lot of
ones.
underground-
Can you see them?
Yeah, that flow uphill. Underground, so you got to go underground to see them.
Right. Or
Looks like
to imagine them. Can I stay up here and imagine them?
You want to call it imagining? Sure, man.
Well, I have to, don't I? Because you're not going to show me any proof of them, are you?
What would you want as proof?
Well, so some sort of evidence. Normally,
Like a picture or a video of an
I don't
underground
know.
river
What,
flowing?
what do you consider a proof of something?
I would accept that as proof, but I don't know if our levels or standards of proof are the same.
You'd accept what as proof? Somebody writing something down and you reading it.
On writing it down and giving me evidence which is verifiable, such as a practical demonstration of this happening in a video or a
Well, if
picture, yeah.
If it's wrote in a book, like you said that you read something out the other day, didn't you? And that your proof of uphill rivers, I think, wasn't it?
I did not try and present that as proof. Maybe I did. Maybe that was proof to back my knowing since childhood Mississippi River flows uphill. Now, admit that I was ignorant in the fact that I just accepted as a kid that it flows uphill and I never questioned it. You know? So I'm starting to question it now as to how this happens. I still don't fully understand how it happens, but it kind of makes sense.
But you've still never been and looked at it and looked into it.
I've never been close enough to the Mississippi River now.
So you've never.
Mississippi,
Like,
it's the other side of the country, man.
it's still a belief. You've never verified it at all.
I haven't verified it, no.
So
You are
you-
right there.
But you know, there's a lot of people I've asked because since you said that I've heard a load of people say that the Mississippi doesn't run uphill.
Really?
Yeah.
Oh, they can say that and they can provide evidence proving that, then I'd like to see it. It's pretty interesting.
Proving that water flows downhill. You need proof to show that water flows downhill, do you?
Oh, I just want proof that the Mississippi River does not flow uphill. So pouring water down
Who would you accept proof from? Because like
Anyone.
I told my
Who from
missus
you?
this the other day. She laughed.
the Mississippi River flows uphill?
Well, I told her that there's somebody I know on the internet that thinks the Mississippi River flows uphill. Yeah, she laughed.
I'm glad I put a smile on her face.
Yeah,
but
I'm
she's
sure.
entitled to find it funny. It's cool. I don't have a problem with that.
No. But like I'm saying, that even she would struggle to wonder why somebody needs proof that a river doesn't flow uphill. Is what
Fine,
I'm saying
man.
is so, like what sort
know.
of
I
what
fully-
sort
I
of
fully
proof would you
understand.
accept?
The Mississippi River flows.
Could we-
That does not flow
Could
uphill?
could I show you a picture of a river flowing downhill? Like
I wouldn't
lots
accept
of
that.
them. Like what sort of proof would you accept to?
I would need you to falsify evidence I presented.
Okay, so I would need to not be able to show you a picture of a river flowing uphill.
No, you would need to show me that it is impossible on a globe Earth is spinning on its axis for water to flow from a point closer to the center of the Earth to a point further away from the center of the Earth. If the Coriolis, the centrifugal pseudo force overpowered gravity.
Okay.
You need to show that if all those conditions came into being, water would still not flow up.
Do you know much about logic? Like,
Yes.
could we compare this to the Black Swan? Not QE's Black Swan, but just the Black Swan, right?
General.
The logical Black Swan argument.
Yeah, you could, because most people's white swan would be all rivers flow downhill, and then
Yep.
the black swan would be this river that flows uphill, right?
Okay, so like in order for you to make the claim that rivers flow uphill, then surely you would have to show us your Black Swan, which would be a river flowing uphill. Can you
So-
supply us with such evidence of your Black Swan of rivers flowing uphill? Because it's an extraordinary claim that needs to be, I don't know, a little bit of proof.
Okay.
Yeah,
Let me try and find a video
a video,
that's happening.
yeah, of water flowing
Yeah.
uphill on the Mississippi, or is this another river we're going to bring somewhere else in?
It's fine if I bring another river, or does it have to be the Mississippi?
Well, I don't know. I mean, like if we can add more rivers, I'm keen to know. So we've got the St. Lawrence River. Zanuck claimed American Geodetic Society measured uphill. You've got your claim that you were taught it in school, American school system, Mississippi uphill river, and which one's the new one we're adding? I'm curious. We'll put it on the list.
I don't know. Whatever I can find, whatever video I can find.
Oh, you're looking for one now. Do you not have it?
I'm
at
looking for
hand?
one right now.
Frantically searching.
I did not
Internet,
have it at hand. Yes.
Please,
I'm
rivers
just
flowing uphill.
Searching, Chris.
Where do you
I
reckon?
wanna
Anyone
get
else
your
want to
request.
guess? I go India. Anyone else?
What?
I don't know.
You saying, Bev?
We're narrowing your searches down for you. Just come on. We're having a bet where you're going to find your evidence of uphill rivers.
Patagonia. Micronesia.
Who's your uphill waterman? Zanuck? You're going to ask Zanuck. Oh, has he gone? No.
No, still here.
Zanuck, quick. Zanuck, where's the uphill river? He'll give you the National Geographic Society. Do you want me to get it? I'll get it for you, his quote. Videos. There we go. Zanuck, uphill rivers. Upload. I'll play it.
Well, no, this shows that the St. Lawrence River has been the U.S. Geology Society has measured this river to be 8 meters higher at the mouth than at the source.
It's 8 meters higher at the mouth than the source. The US Geological Society. I think that's what he says. He mumbles a bit of it, but yeah.
8 meters higher.
Yeah, the US.
And how long's the course of the Mississippi?
No, that's the St. Lawrence River.
I found the video. Trying to get the timestamp.
The St. Lawrence River is the one with all of the Great Lakes in it. You know that one?
Uh-huh.
In Canada.
Copy video at current time. Bev, I found a video. It's pretty short and sweet.
Sweet.
I put a timestamp, but if you want to watch it from the beginning.
Well, not all of them.
Oh, like, see that? Crookshanks has done that one as well. See if anybody have a look at that picture that Crookshanks has put up. Have a note, please, of the red line in the middle that says true horizontal thing. And have a look at the shape of that. As a horizontal, true horizontal distance there. Ooh.
It says, as the tide continues rising, this river is tidal. This is a tidal bore. This happens in the UK as well. The river isn't actually flowing uphill.
That from the video I posted?
Click the link you post. What was it? Rivers run uphill. No, he said, as he said,
movie tone.
At that time
they surf
stamp
it every
you
year,
gave.
don't they?
Yeah, there's tidal bores all over the world. So at 125, it says, as the tide is rising, it's a tidal river.
I can see what you've done there, Nate. You've gone and Googled uphill rivers, haven't you?
Yeah, just click the first link you come to.
The river runs uphill, yeah.
Yeah, but it's
no,
not.
it doesn't. It doesn't run uphill.
But that's what you guys wanted. It does.
No. This is a tidal river, and it's a tidal bore that runs against the incoming tide. It's not a river flowing uphill. It's a tidal bore. Do some research into a tidal bore and see how it works.
About that, man. This doesn't say anything about tidal bores.
Do you know anything about tidal bores? Nate?
He obviously lives inland.
Yeah, you do.
I know what a tidal bore is. No, I live in New York City, so that Atlantic Ocean is right there. I know what a tidal bore is. I'm watching the whole video. They didn't say anything about a tidal bore.
Well, if you go to the timestamp that you gave, the 123, so go to 121 and listen to what he says. As the tide continues rising, this is a tidal river. It's not flowing uphill. There is more tidal surge coming inland than there is water flowing out to sea.
That doesn't meet the criteria you guys are looking for.
Well, no, because you're saying about a river flowing downhill, and that's not happening in the example you've just supplied. Sorry, you said about a river flowing uphill. I made that mistake yesterday. And that's not happening in the example you supplied. This is a tidal river where the incoming tide is flowing against the outflowing water. So therefore, the water appears to be flowing uphill into the flow of the river. But it's not. It's a tidal mass that's flowing up the river.
They surf it, don't they? It's like it's a wave.
So isn't that a river?
No,
right.
No, it's not, is it?
Okay.
No.
What exactly do you guys want? Like what? Let me try see Mississippi River.
That only happens at certain times of the year on certain high tides.
Yeah, it doesn't happen every day.
It's not. It doesn't. There isn't a bit where the river sort of. It's a bit where it goes uphill. That's not what's happening there.
It is effectively a tidal surge. It's just a surge of water running up the course of the river.
Causing it to flow backwards.
No, it doesn't flow backwards. It's just the water is still flowing out to sea. It's just that there's a greater mass of water coming in the mouth of the river than there is going out of the river. And it only lasts for, well, you get one tidal surge up the course of the river. And it doesn't flow back to the source of the river. It only happens along the tidal part of that river. So if it happened on the River Thames, it would only flow, the tidal surge would only flow as far as, I think it's Richmond upon Thames,
Dude.
where the tidal part of the river ends.
You need to put a monkey on that thing, DP.
Sorry?
Okay.
Monkey it up. I'm gonna
monkey it up.
Yeah,
okay.
please. Nate, I know this river thing. You're not really doing too well. But
yeah, I'm not doing too well in terms of giving you guys what you want.
Yes.
I apologize. Maybe I need a bit more time.
Yeah. You can go away and research that. I mean, I need to go.
I don't want to go away. Maybe we can talk about something else.
Yeah. I would say I'm gonna make a brew for the missus, and then I've got a few things I'd like to run by you. 8 statements about something I'd like to just test and run by you. I want to try and clean it up, but I mean I'll be gone for a few minutes. No doubt you've got something you want to talk about. Gravity with Tony. Tony, he likes.
If he wants to talk about it.
Yeah, Tony loves gravity. It's his pet subject.
Yeah, I'm here. So what do we want to talk about gravity for? Do we want to talk about whether it can make things happen, or is it the result of things happening?
Which gravity?
Well, there's only one gravity. We know what it is. It's defined, and we know what causes it by current physics.
We not still use classical mechanics and Newtonian physics?
I said in current physics. In current physics, we don't use Newtonian gravitation anymore. That was replaced in
classical mechanics doesn't form part of current physics.
Classical mechanics doesn't form part of gravity in current physics. It's mathematical in nature, and it can represent what we see, but in physics, we're looking for what's causing what we see. And we know what gravity is because it's defined, and we know what causes it because that's also defined. And that is the current position in physics is not Newtonian.
Yeah, definitely. In terms of the cause, there is no cause from a Newtonian perspective. I agree with you there. If you want to talk about the cause of gravity, yes.
Well, we need to know the cause if we're going to. We need to know the cause of gravity if we're going to be making claims to do with gravity.
Right. So the cause of gravity, according to Einstein, is matter bending space-time.
No, that's the effect. The cause, according to Einstein, is the uneven distribution of mass.
Okay. Right, cool. Uneven distribution of mass in space-time, which causes space-time to bend.
Let's get it concise. It's the uneven distribution of mass that causes the effect of the curvature of space-time, which we perceive as a force, but it's not actually a force. It's the warping of space-time.
Yeah.
It's not even I don't like using the word pseudo-force because that kind of reifies something as a force when it's not a force. It's like non-Euclidean geometry. You guys think that non-Euclidean geometry can explain how a straight line can be a curve. Well, let's call it fake geometry. Well, let's not call it a pseudo-force. Let's just call it not a force. Let's call it an effect, because that's what it's defined as.
To call it a pseudo-force, because we see
No. We'll call it an effect. Because that's
between matter and space, causing matter to move. In order for this to work,
we're not going to call it. Forgive me. We're not going to call it a pseudo-force. We're going to call it an effect, because that's how it's defined.
Want to call it an effect, we'll call it an effect.
Yeah. So in the context of, were we talking about water flowing up a hill? How would water flowing up a hill be caused by an effect of gravity or an effect of the curvature of space-time?
Oh, it's not gravity that causes this to happen. It's the Earth spinning on its axis, the centrifugal pseudoforce, overcoming the effect of gravity.
Oh, really? So my understanding was, I wasn't really listening to the previous conversation, but my understanding was it was gravity. It was gravity causing it. If it's not that, and it's an effect of centrifugal force, then how would we know that it was a centrifugal force effect rather than just claiming it?
How would we know it's a centrifugal force causing this to happen? Is that your question?
Yeah, rather than just saying it, how would we prove that it was actually true?
That is a good question. How would I prove? I mean, I understand how it would work. How would I prove that to someone else? That is a good question.
Well, here's how I understand it.
I don't have the answer for it.
Here's how I understand it, and you can correct me if I'm wrong, but a centrifugal force works on the inside of a container. So whatever the container is, be it a fish tank that's spinning like Wolfie showed, or a gravitron, a fairground ride, if it's contained, it can be pushed against that container and it can give movement. But if it's not being pushed against a container, it just flings off it, because it would be on the outside of the container and it would fling off it.
So if I was on a merry-go-round and I wasn't in the okay, I see how this would work, like in the as something in a container, but on a merry-go-round, it's just to say that the centrifugal force is opposite from the centripetal force. The vector in the centrifugal force points out towards the outer edges of the object spinning, while with the centripetal force, it points inwards towards the center.
No.
So yes, you are right.
No, you got that wrong. The centrifugal force is the apparent force that appears to push an object towards the circumference of its rotation point, but the centripetal
force... Yes, it's an apparent force, but its vector points towards the circumference. But the centripetal, the vector points towards the center. We agree.
Right. So yeah, that's right. Yeah. So if we're on the outside edge of a sphere, and we are turning, then would it be centrifugal or centripetal force that we would be trying to demonstrate?
Centrifugal.
Because something's spinning and we're being pushed away from it, right? But the thing's not being sent off into space, is it? So it's being held back somehow.
The effects of gravity is keeping the water in its stream.
Well, no, we know that the effects of gravity curve space-time. They don't do anything with water.
Water is affected by gravity.
How can you explain to me how water how the curvature of space-time causes water to do something? Sorry, let me just rephrase that. I've slightly misworded that.
Yeah.
Can you explain to me how the uneven distribution of mass causes water to do something?
So if you were to look at space-time as fabric along which, or the floor along which we walk and do things, mass is distributed unevenly along this floor, to cause indentations in the floor, right? Going to cause curvature within the floor.
Yeah, but that's not what space-time is defined as. Space-time is a mathematical construct that is only represented mathematically. It doesn't have any tangible attribute to it. It's just.
I know, but I'm trying to conceptualize it first. Like a visual image.
Your conceptualization involves walking on terra. Hang on, forgive me. Hang on. Your conceptualization involved walking on terra firma. That's not space-time.
It's not. But I'm trying to give you a visual concept. But if you don't want that and you want pure mathematics, we can go through the math.
No, I don't want mathematics. I want how space-time, how the effects of uneven distribution of mass bends the space-time, but does something to water. How does that happen?
Right. If I can't explain it to you with an analogy or a visual concept, and if I can't explain it to you mathematics, I'm not sure how else Explain it.
You can explain it to me, but you can't use terra firma because walking on land isn't space-time bending. Space-time bending is a mathematical construct, so you've got to describe it mathematically. And if you don't want to, I can get that because I couldn't do it either.
No, I want to describe it mathematically, but you told me you don't want the maths.
Okay, well, feel free, go ahead. But what I'm asking you is, if you describe it mathematically, is that going to show me how water behaves on Earth?
Would shine some light onto it. It wouldn't give you a full, detailed understanding, but it would explain to you how Earth's gravity affects water.
Could you explain it with a Minkowski, Minkowski diagram? Because that's how they diagram it mathematically. Yeah, that's what you're after. It's a space-time diagram, right, Nate? Is that what you're after? You're trying to conceptualize it so everyone can understand it, and you said you wanted to explain it mathematically. Well, is that how you do it? I'll put it in the chat for everyone if they want.
I mean, I know what a Minkowski diagram is. I just don't know what it is you're trying to say. But...
Well, you were trying to explain it to everybody, right?
Yes.
Because we want to know how water can flow uphill. Now, if you're going to say gravity, and we know what gravity is, we've just been through that, and if you're going to calculate it, that's great, but I want you to explain how it makes water move on Earth. So if you're going to go mathematically, that's fine, but I still want to see how it explains water flowing up a hill.
Okay, so as I said, the effects of gravity is what would keep water from flying off the Earth as it's spinning, but what's making the water flow uphill is the centrifugal pseudoforce.
But centrifugal force pushes an object away from its mass, its rotation of mass, right?
Yes.
So how is that going to do it?
It's pushing the water away from where mass is strongest to where mass is, well, not mass, sorry, where the effects of gravity are strongest, where the effects of gravity are weakest. And that would be, just to put it in different terms, moving the water away from a point where it's closer to the center of mass to a point where it's further away from the center of mass. From the poles to the equator.
Hang on. So what you seem to be conflating, what you say is the effects of gravity, which we know is the curvature of space-time. You seem to be conflating that with centrifugal force, and I'm trying to see how they correlate or how they're linked.
I don't see the conflation. Maybe you could point it out to me.
Well, you're conflating centrifugal force with the effects of gravity to try and explain water flowing up a hill. How are they?
But how am I conflating?
Because you're talking about the two items in conjunction with each other. You're conflating between the two of them, and I'm saying, well, how does that explain water flowing up a hill?
Gravity is not what makes water flow up a hill.
Okay. Does it have any effect?
Is what stops water from floating off into space. It's what stops you and I from floating up into space.
So it's not centripetal force that stops that. And I thought gravity was the bending of space-time. I don't see how the bending of space-time causes water to not fling off into space. I thought that was centripetal.
So I'll say it again. Gravity is what stops water, you, and myself floating off into space.
How
makes the Mississippi River flow uphill, though.
How does it do that?
Centrifugal pseudoforce.
How does gravity do that, given that it's an effect?
How does gravity stop us from floating off into the air?
Yeah, the second part was given that it's an effect.
Well, this is making it a bit tricky for me. I don't see gravity as an effect. It's kind of a situation where I need to put myself in your shoe.
What do you see gravity the way?
Hang on, Bev. I need to see gravity the way Sleeping Warrior sees gravity and then explain it to him.
No.
Difficult.
No.
I don't see gravity as
forgive me. This is not my perception. This is your current physics. Gravity is an effect. So if you're going to explain to me that it stops us from flinging off into space, I'd like to know how that effect does that, because it must be. Well, I don't know. You tell me, because I can't do it. This is not my interpretation, though. This is your current physics.
But I've never seen anywhere where gravity is being described as an effect. And this is current physics. If you could pose something where gravity is said to be an effect and how they explain it to be so.
Okay, so should we start with something that's easily digestible? Because if we go in too deep first, you're not going to accept it. So let's start with something simple. I'm just going to go to Wikipedia. This is your current, generally your starting place as a ball earther. Is Wikipedia acceptable for you?
I have the Wikipedia page open for the definition of gravity.
I get you open your mind really first though, because George Musa, quote, "Gravity is not a force, but you can think of it as a force." So is that where we're headed here, Nate?
Well, hang on. That was jumping in. That was getting balls deep. We'll come to him in a sec. Let's just see if we can get him to agree Wikipedia first. Then we'll come to others. Do you agree? This is the paragraph 2 of the heading in Wikipedia cited gravity. You can look it up yourself. It says, gravity is most accurately described by the general theory of relativity proposed by Einstein in 1915, which describes gravity not as a force, but as a consequence of the curvature of space-time caused by the uneven distribution of mass. So if you're going to say the effects of gravity, we know that the effects of gravity are the curvature of space-time. And we know that the cause of that effect is the uneven distribution of mass. So what I want you to do is express to me how it is that water flows up a hill by using the uneven distribution of mass as the thing that does it.
It again. What causes water to flow up a hill is the centrifugal force, not gravity.
Oh, right, so it's not gravity then?
I've never said it was gravity.
You did, you said it was the effects of gravity. Stop it from
cause water to flow up a hill? No, what I said, gravity is what stops water floating off into space. Stops you and I floating off into space.
So let's just be clear so that we've got the terms. The thing that makes water flow uphill is not gravity, it's centrifugal force. Is that correct?
Checking for the
so
okay.
I'm writing it down in the live stream so that it's there in Word and there's no more confusion.
Can I just jump in here, Tony? For I want to do this before I take to Nathan's shortly, so you can get back to this in a bit. Nate, can I just run you through these 8 statements? We'll call them. Do you want to go with statements, or do you want me to turn them into questions? This is
clever, Bev.
Just a quick test.
I'm not sure what I'm in for, so.
Well, it's just simple questions.
Go ahead.
So, do you want them in
simple questions? Go ahead.
Statement form, then, right? Would you agree? Statements, right? Straight lines don't bend. These are like a sequence. We have to go through them step by step. There's 8 in sequence, but we have to go through them, right? So, first statement, I would say, straight lines are by fact not curved. To differentiate a straight line from a curved line, it has to be different in the way that there are no curves in it. So a straight line doesn't curve. Doesn't bend or anything. A straight line, by definition, straight line. Would you agree?
Straight lines curve.
So you disagree at step
I
1?
don't think I agree. I don't think. Well, not about disagreeing or disagreeing. It's a question.
Well, no. I'm making a statement here that straight lines don't curve. Do you agree or disagree with my statement?
Ask you a question first before I answer.
Wow,
if I drew a straight line on a curved surface, you say that line is straight or curved?
The curved surface is curved.
The line is straight.
No, the line would be curved, wouldn't it? Come on. In order for a line to be straight, it has to be free from curvature. Do you agree or disagree?
I disagree because I feel I can draw a straight line on a curved surface.
Then that would be a curved line, though, wouldn't it?
Oh, I would still call that line straight.
Well, I don't think there's anywhere else we can go with this. If you,
all right. No, actually, then I agree with you.
oh
Straight
right,
lines cannot curve. Yeah, I agree with you. Straight lines cannot curve or bend because then
logically.
it's not straight anymore.
Yeah, right.
But
Yeah.
if I draw a straight line on a curved surface, line is still straight.
No, it's a curved line because it's on a curved surface. You can't have.
Okay, there we agree, we disagree, but I agree with your initial statement. Straight lines do not curve.
Ever, in any direction, in
Ever. The
Right.
moment it starts curving, it's not straight anymore.
brilliant.
But I can draw a straight line on a curved surface.
How?
Zing.
How would you draw a straight line on a
Never-
curved surface, and not make it curved? How would that happen?
Nate, what he's telling you is that you can't be in and out at the same time. If the line is straight, therefore it cannot be curved because it's already a straight line.
Hang on, don't obfuscate. Let him answer that question. Ask it again, Bev.
Straight lines. You cannot draw a straight line on a curved surface because it would then curve, wouldn't it? Like you were literally saying it's a curved surface, Nate. So you cannot have a straight line on a curved surface, can you?
Can, Bev. I could draw 3 straight lines on an egg, and they would all meet at 90 degrees. It would be an so it would be a triangle with 2.
Who's feeding you information there, Nate?
On, but I just need to think of
I think we nearly heard them then, didn't we?
I could draw a triangle with 3 straight lines on an egg,
On what? Sorry.
all sides being 90 degrees.
Sorry. What was that you said? You could draw
I
a.
said I could draw a triangle
Right.
on the surface of an egg.
How would you define a triangle? Like we're starting on straight lines and you're going off somewhere. The question was straight lines. It was a statement, really, wasn't it? Should I
Are you cut out?
statement again?
Bev, can you rejoin, mate? You're dropping.
Yeah, you're dropping.
Something while Bev gets back.
Yeah, go on.
Okay.
You had your chance then, Ted.
Yeah. Okay. So here's the deal. I just came on and I heard a little snippet of this. So I must say I haven't heard the whole conversation. But this gentleman that Bev is talking to said logically he agrees, but then he says the opposite.
Mm-hmm.
Do you know what the law of non-contradiction is, sir? In logic?
I just don't see how I.
No, that's a direct question. Do you know what the law of non-contradiction is in logic?
Yeah, I know what it is. I just don't see where the contradictions.
Hang
Maybe you
on.
could point it out.
Yeah, the chief principle of logic is the law of non-contradiction. I'm reading this. Something cannot be what it is and not be what it is at the same time and in the same sense or relationship. A cannot be A and minus A or non-A at the same time and in the same relationship. You're saying it's straight, but it's also curved. That's violation of logic.
Yeah, but it was only question 1. So, like, in order for the sakes for me to get through this, because I wanted to go on Nathan and I talked to Nathan.
I just posted something,
Uphill
an image
rivers.
that is longitude and latitudinal lines. Those lines not straight.
They're on a
Are they on
curved
the curved
surface.
surface?
So because they're on a curved surface and they're
You
not
tell us.
straight.
You tell us. Are those lines straight or are those lines curved?
I say those lines are straight. You guys say they're not because the surface isn't flat.
Brilliant.
So is there a change in direction at any point along any of them lines?
No.
Yeah, there is. There's a continuous change all the time.
Yeah, them straight lines seem to go back to the same point again, much like a circle, right, Nate?
Yeah.
Is that a known fact for straight lines to return to the same point?
Known fact that you can draw straight lines on a 3D surface.
So are you
they
saying
would
the
obviously
surface?
return back to their source.
So are you saying the surface of
is
the?
curved.
So are you saying the surface of the Earth is straight now instead of curved?
Yeah, you must be.
No. Earth's surface is curved. That's why latitudinal
But you just said that was. You just said that was
lines
straight. You just said that
That's
they were
straight.
straight lines.
Earth's surface
So,
straight lines on a curved surface. That's
so if
what
the straight lines, then it
latitudinal
must be
and
flat.
longitudinal lines are.
That's an oxymoron, that, you know.
No,
You're
it's not.
violating logic.
Or the Earth's flat. Because if you're saying those lines are actually straight, then it means that we must live on a straight plane. Then.
And that's just an imagined shape in his head, right?
Yeah.
Yeah. I go with that.
Which,
General
If you can imagine straight lines to turn round and go back to
modern
themselves,
physics.
then...
I mean, this is geometry.
Yeah, geometry. And there's a difference in geometry between a straight line and a curved line, isn't there?
Big difference. The lines in the image I just posted.
Do you want,
Straight.
I'll see if I can find a thing about in Euclid, because seeing as you're talking about geometry, then...
so hang on, whilst he's looking for that, let me ask you this. If you think that straight lines can be curved lines, does that then follow that you believe that curved lines can also be straight? It must do, right?
If I try to draw a curved line on a flat surface, that line becomes straight.
So then how would you distinguish? How would you be able to distinguish our terrain from either? Because if you're saying that one can be the other and the other can be the other, that would be a direct contradiction of the law of non-contradiction. So I would say, well, how do you know that it's a sphere then? How do you know it's a sphere if straight lines can be curved, but curved lines can be straight too?
Never said straight curved lines can be straight or that straight lines can be curved. Those lines I'm showing you in that image are straight.
No, you did.
Oh, when? What did I say?
Just before.
So when you put your picture up of the globe with the longitudinal lines and the latitudinal lines, you said that they appear straight, and we said they're
they are
curved.
straight.
Okay, so and then I asked you, well, if you think that curved lines can be straight, do you also think that straight lines can be curved? Do you want to re-answer that question?
And I didn't answer the question. I just asked the question back to myself. And
okay, so what's the answer then?
I think I'm kind of no. The answer is to your question is no, and I feel I'm being misrepresented because I didn't once say straight lines can be curved. I agreed with Bev's initial statement: a straight line cannot curve. What I'm saying is,
just clarify, you did say that those curved lines on the longitude and latitude lines, you did say that those curved lines were straight, did you not?
what I'm saying is those lines are straight. I'm not saying those curved lines.
So if those
latitudinal and longitudinal lines straight. You keep saying they're curved. I'm not saying that.
Oh my gosh. Are you saying that we're saying what you're saying?
No. I'm saying you're saying something very different.
Okay,
Trying
look,
to make me answer that.
No, there's a straight line and then there are curved lines. Do you know the difference?
You know what the difference is? And what I'm saying
what's the difference?
The difference is straight lines don't bend. Now,
okay, so,
in that image I posted, those lines are straight. Just because the surface is bending doesn't mean they're bending.
Oh.
Yeah.
So what's the disconnect if I take a permanent marker and I get a basketball and I hold the marker on it and someone rotates the ball underneath? Is that a straight line or is that a curved line because it's on a curved ball?
Straight line.
Well, how could it be a straight line on a curved surface?
The line isn't bending; it's straight.
It is bending.
The surface that it's on is bending. The surface doesn't dictate the line itself.
What?
What are you talking about?
You guys are saying because the surface is bending, the line must be bending as well. And I'm saying no.
All right. Then with that logic, the Earth is flat.
No. Can I just add in here?
The sphere is flat. The sphere is flat.
Gauss, with his mathematics and his model of mathematics, actually determined how you could find out the shape of an object through mathematics. Do you know what that is, Nate? How he did that?
I don't know what mathematics is. I'm not sure who you're talking about though.
What? Who else? Somebody else pipe up then. We've got another
Oh,
one.
you keep on saying someone's name. Someone said through mathematics. Who is it you're talking about?
He's like, you gonna quick do the thing. Did I hear somebody shout in the background that we don't know anything about mathematics? Have you got somebody there with you on a keyboard? Gauss. Have a look. Look it up quick. See what he
Gauss,
said.
yeah, I know who Gauss is.
Right, so what did he say mathematically, how you can tell the shape of an object?
Sure what he said.
Oh, you're not sure what he said?
Mathematics and the shape
It
of
was
an object.
about...
He said a lot of things.
Yeah, it's triangles, isn't it? You can measure the shape of an object by the internal angles of a triangle. Right? And a triangle has 3 straight sides and 180-degree internal angles, doesn't it? Do you know any other definition of a triangle? Is there anybody else knows any other definition of a triangle that encompasses all of the triangles? 3 straight sides, 180-degree internal angles. Anything else?
I think we need to focus on the line bit.
Straight lines, right?
Triangles can have the sum of their internal angles being more or less than 180.
Can they?
Degrees.
Can they?
Yes.
Where?
Yes.
Which geometry that's talking about?
Say non-Euclidean, but it's accepted in mainstream geometry and mathematics.
That you can have triangles.
I would say mainly in spherical geometry.
Right, so that would be really handy, right, if we know what a straight line is, wouldn't it? In order to understand a triangle, we're at the straight line. Question number 1. I've only got 8 questions. They're not really hard. You've got stuck at number 1. Straight lines. Do they bend? I say they don't.
I totally agree with you. Straight lines do not bend.
Brilliant. Step 2.
We agree with
question number 2. Straight line is different than a curved line. Right? You have to be in order to differentiate between the two of them. Yeah, brilliant.
Agreed.
So, a perpendicular, mathematically, do you know what that is? Perpendicular requires 2 straight lines, 90 degrees in between them. Yeah, perpendicular. Right? You would agree. Mathematically, a perpendicular requires 2 straight lines.
I would say perpendicular requires lines to meet at 90 degrees.
Yeah, 2 straight lines. Because we're being mathematical here about this. We're talking geometrically. That is defined as 2 straight lines meeting 90 degrees perpendicular. Because you can't have a straight line meeting a curve. Because you need 2 straight lines for a perpendicular. Would you agree? That's me making a statement of fact. Do you agree with it?
At only straight lines can be perpendicular?
In order to form a perpendicular, you need a straight line, and the perpendicular that is formed to that straight line will be a straight line. That is a perpendicular. Do you agree?
I think as long as the lines meet at 90 degrees, they are perpendicular. Hold that they have to be straight thing, I don't agree with that.
So you
intersecting lines that meet 90 degrees are perpendicular.
So what we're looking for is you with some sort of a mathematical geometrical source that says perpendiculars can be bendy lines. Okay? But I mean, we'll carry on. We'll take it as though you accept that as a truth, right? Perpendiculars, like you're willing to go along with they need to be straight up until the fact that you can prove that they don't need to be straight. But until then, can we go along with straight lines? Are you happy with that?
Sure.
Right.
Sure.
Now, vertical and horizontal are known as being perpendicular to each other. That is a statement. That was a quick one, yeah? You're going along with that?
Yeah.
Yep. Now, in order to realise these, because these are just sort of mathematical, well, vertical and horizontal are, but perpendicular is a mathematical statement. So we realise this now. A plumb bob is a vertical. That's how you would establish a vertical in reality, right? Plumb bob. The tool.
A plumb bob is how you would establish perpendicular against.
No, not perpendicular, just vertical. Is a plumb bob a tool to establish a vertical line of reference? It is, because that's what bricklayers and people practically use in things. That if they want to establish a vertical, they would get a plumb bob. It's a tool, isn't it? It's a practical tool to establish a vertical. Would you give us that?
To establish a vertical datum, right? Yeah. Okay.
Okay. You're taking a while. You have to Google all of this stuff.
Because I have to think about it, man. Like, I don't just want to answer without putting thought into it.
Okay. So that's the practical use of the vertical, and the practical use of the horizontal would be a level, right? So the reality version of the plumb bob, but in a horizontal form, is called a level. Would you go along with that?
Okay, we'll go along with it.
Okay. Now, a level tool and a plumb bob they're both the reality things. Now, they work completely independently of each other, don't they? I can have a plumb bob in one hand and a level in the other, and there's no way that either of those two things are connected to each other.
Yes.
Right. Now, would you agree that level is the practical use of the word horizontal? So when somebody says, is that level, do they mean, is that horizontal? Is that in the horizontal position?
Yeah.
Yeah. So
I would go along with that. Okay. Yeah.
So the water level is horizontal. Would you agree with that? Yes?
I guess.
Are you just guessing, or are you Googling?
I'm guessing because you're not giving me time to think about it. So I'm just going to guess and say, yeah, I agree with you.
Okay.
I'm not Googling anything, but I mean, if you don't give me time to think about it in my head, try and conceptualize it and understand it, I'm going to have to guess.
Well, no.
So yes, I guess you're right.
I'm just making statements here that I think are facts.
I know, but I do understand we're pressed for time.
Okay, so the water.
Yes, I guess you're right.
If the water level is horizontal, how do you get a horizontal to wrap around a ball?
I would say because level doesn't mean straight.
Oh, so we go back to what? Which was that? Question 5. A level establishes horizontal. Yeah? Or no?
Yeah.
That's still like a level
I'll
establishes
go
a
along with your
horizontal.
question. But clearly there's a flaw in your question. There's a question I shouldn't be agreeing with. Because I don't have time to think about it. I'm gonna just agree with everything.
Oh, right.
It makes the questioning pointless.
Well,
I just agree with it all.
But I'm just making simple statements, Anna. As far as I was aware.
These statements are not simple.
They're not simple. Like, straight lines don't bend.
That one was simple, but
yeah. Straight lines are needed for a perpendicular.
Establish horizontal.
What?
No, it's just that black and white, man. Don't they only establish horizontal at a specific point?
Yeah, horizontal. Yeah, you can move it to wherever you want, but as long as it's the bubbles in the middle, then it's horizontal, and horizontal's horizontal. Right? It's a very definite position, isn't it? Yeah.
That's over a set length or distance, right?
What, a horizontal line?
Level.
Yeah, level. If level establishes a horizontal, we're talking about level being horizontal. It's the same thing. So are you talking about a horizontal bending at a certain point?
Oh, I'm saying a level establishes horizontal at a specific point or over a set distance.
Yeah, how that set distance would be however long your water level pipe would be, wouldn't it?
Exactly. And I can have horizontals different angles.
Sorry? Say that again.
I could have horizontals at different angles as long as my horizontals
different angles to what?
Each other. Or maybe not. Yeah, if they met, they would meet at an angle. They wouldn't meet at a straight line, is what I mean to say. So
are you talking about horizontals on a horizontal plane?
I'm talking about if I drew a horizontal line that is perpendicular to plumb, and you drew a horizontal line that is perpendicular to plumb, those lines would not meet in a straight line. They would meet at an angle.
No, they'd be parallel. They'd have to be, wouldn't they, geometrically?
No, they wouldn't be parallel because plumb is different for both of us. Because we're at opposite sides of the Earth. Plumb is pointing to the center of the Earth for both of us.
Sorry?
So because we're at different places on the surface of the Earth, plumb is pointing down towards the center of the Earth. Both of us.
You reckon?
You reckon?
Yeah. You reckon the difference, the vertical is different to you? How much would you reckon that your vertical differs angularly to my vertical? Well, just as an estimate, how much angular difference would you reckon that there would be?
You're in England, right? And I'm in New York. So if we drew two verticals from where...
No, if we both, if we both hold our plumb bobs out in front of us.
We imagine those plumb bobs extended until they met at the center of the Earth. What would that angle be?
Well, if that is that what you want to imagine? Yeah, I'm asking you, like, would there be an angular change between the two? And what do you estimate that angle would be?
It could be anything. I would say anything between 30 and 60 degrees. I could be wrong.
Okay, so
not more than 90.
You know, when we said earlier, we said vertical and horizontal are perpendicular. Do you understand what that means?
I understand what that means.
You do understand what that means.
Yeah. So maybe let me try and explain it back to you now. If you had a plumb bob and I had a plumb bob, and we use those as our verticals, you being in England and I being on the west coast of USA.
Yeah.
Our verticals would meet at an angle. Our verticals are not parallel to each other. Meet at an angle. Because our verticals are not parallel and they would meet at an angle, our horizontals, which need to be perpendicular to our verticals, would also meet at an angle. They would not meet at straight. They would not intersect as a straight line.
Okay, so your horizontal would not be perpendicular to my vertical. Is that what you're saying?
My horizontal would not be
Yeah?
exactly what I'm saying.
Is that what you're saying?
That's exactly what I'm saying, yes.
You're saying that vertical isn't perpendicular to horizontal.
I'm saying vertical is perpendicular, but my vertical would not be perpendicular to your horizontal.
Do you know what Ten said a bit earlier about the law of non-contradiction? Like,
there's no contradiction.
In geometry is based on logic, right?
It is based on logic.
You've just made a vital misstep in logic. Yeah. You've just imagine, right? Let's say I'm at the North Pole with the Polaris at my zenith, right? And you are at Ecuador, right? Now, your vertical, is that going to be perpendicular to my vertical?
My vertical, it could be.
It could be.
Ecuador is 90 degrees away angularly from the North Pole, then yes, it would be perpendicular to your vertical. That's exactly what I'm saying.
Yeah, that makes perfect sense, doesn't it? What form of logic does that make sense?
Perfect sense to me.
Well, yeah, I'm not surprised it makes perfect sense to you.
Most surveyors, when I look it up, that's what, all of these images are telling me.
You're talking to surveyors that are saying that.
I'm looking at what surveyors have posted.
Oh, where have these surveyors posted that? I'd be interested to see where they've... can you remember which surveyors it was that were posting that?
I'll try and find it for you, man.
Yeah, please.
That's how I understand. If you don't agree, it's fine.
Yeah.
But that's how I understand it. And yeah, if you want to change my mind on it, you're going to have to bring something.
It's pretty clear that changing your mind's a pretty hard job.
Yeah,
you seem pretty set in your ways of...
I could say the same right back at you. I think we're going to change each other's minds here, which is fine.
See, I still go along with the fact that vertical and horizontal are perpendicular. I use it that way practically.
I agree with you 100% that vertical and horizontal are perpendicular. I totally agree with you. But if we have two different verticals, two different locations on Earth, their horizontals not be perpendicular to the respective verticals.
Yeah, I don't think you even know what you're saying anymore, Nate.
I think either you don't understand what I'm saying or you refuse to understand. So if you drew a vertical line or horizontal line that you draw on that vertical would be perpendicular to it. But if I drew a horizontal line in a different location on a different part of Earth's surface, vertical I draw as perpendicular to my horizontal, not be perpendicular to your horizontal.
Okay, just before I go, Nate, right? We're at the canal. You at one end of the canal, and you drop a plumb bob to the water level, right? Now that plumb bob's perpendicular or is vertical, and that's going to hit the water, which is horizontal level, perpendicularly, right? Two practical tools used in a practical way, demonstrated geometrically, vertical, horizontal, meeting each other, perpendicular. Would you agree?
I would say that at that point,
yeah,
where the plumb is touching the water, it's perpendicular.
Right. Okay.
Once you start moving away from that point, it's not perpendicular anymore.
Yeah, but we're gonna move half a mile down the canal, and we're gonna do exactly the same thing. We're gonna drop our plumb bob vertical, hit the water horizontal, and it's perpendicular. Right?
At that point where you have dropped your plumb bar, it is perpendicular. But if you move away from that point, it's not perpendicular anymore.
Right, so the water level is horizontal.
At that specific point where you've dropped your plumb bar, yes.
Plumb bob. Not plumb bar. Right.
That specific point where you dropped your plumb bob,
yeah,
it's horizontal. At that point.
Okay.
Once you move away from that point, water is not perpendicular to your plumb anymore.
Well, it's not perpendicular to what, Plum?
Or a plumb bob.
Wait, why?
Vertical.
Which, the surface of the water or the plumb bob? Which one alters? Does the surface of the water stop being horizontal, or does the plumb bob stop being a vertical? Which one happens when you walk away?
Water stops being perpendicular, plumb, and you walk away from the point. You drop your plumb bob.
Well, what happens to the? What happens to it if it's not perpendicular? Is it sloping?
Slopes away.
It slopes.
Slopes away.
Slopes.
Slopes away. Water slopes away. It stays level, but it slopes away.
It slopes away in which direction?
It curves downwards away from your datum.
Oh, so it depends which way you walk away from the water, in which direction the water goes away from you.
Good point, yeah, because maybe the water is coming from uphill going down, but you said a canal. I assumed it would be. Yeah.
Yeah, you assumed it would be horizontal, but I would assume it wouldn't move at all. But I mean, you seem to have some sort of way that it moves away from you wherever you are, while staying perpendicular at the point where you drop a vertical to a horizontal, and also with vertical and horizontal being straight lines. So what exactly happens, Nate? How do you make all of that logically fit into one nice package? How do you round all of those straight lines that you've just been talking about? Geometrically, how does that happen?
So if I had put a plumb bob down at all of these points, and now I all have these different level points.
The one level, isn't it?
No.
Yeah, it is. It's one. It's the canal. It's one.
It's all level.
Yeah.
You know, like just like that image I posted now. You see the Earth, and
that's Earth, is it?
Yes, it's a representation of the very crude, middle school, 5-year-old representation of the Earth. But it's just to get the point across.
So where's vertical? Can you mark vertical and horizontal on there for us, please?
If you take any point on the surface of the Earth and you draw a straight line from it, a tangent, that would be your vertical. That tangent would only touch the surface of the circle at one point.
Right. Yeah. Can we do you want to do this later, Nate? Because I'm going to have to go and talk to Nathan about rivers.
That wouldn't be a vertical. That would be a horizontal. Tangent would be a horizontal.
Do you want to take over with Nate here, or? What?
No, I'm going to go and watch Nathan.
Okay. I'm going to go and have a chat with Nathan and jump in the thing earlier. All right. I'll catch you later, guys.
Peace.